Welcome to this session on mathematics, chapter 1 on real numbers for class 10. We are doing section 1.4 revisiting irrational numbers, exercise 1.3, questions number 1 and 2. Question number 1. Prove that square root of 5 is irrational. So let's start solving this problem by assuming the opposite. That is, let's say that the square root of 5 is a rational number. So if this is a rational number, then we can find two co-prime numbers a and b such that b is not equal to 0 and square root of 5 is equal to a divided by b. If we rearrange this equation, we get 5b square is equal to a square, which implies that a square is divisible by 5 because we have 5 here and then some other value of the integer is equal to a square. So we can say that a square is divisible by 5. Now using the theorem 1.3, which says that if a number divides a square, then this number divides the number a as well. So if a square is divisible by 5, then a is also divisible by 5. So this is what we conclude here. Now let's say that if 5 can divide a, then a can be written in the terms of 5. That is, let's write a as a is equal to 5c, where c is some integer. Now if we rearrange this equation and if we use the value of a from the equation 1, that is a square is equal to 5b square, we get b square is equal to 5 times c square, which implies that b square is divisible by 5 because we have 5 as a factor of b square. Now again using theorem 1.3, we get that b is divisible by 5. So if we see these two equations that we have arrived at, that b is divisible by 5 and a is divisible by 5, we see that a and b have 5 as a common factor. But we realize that this is contrary to the fact that both a and b are co-primes, because co-primes have only one highest common factor, HCF, which is equal to number 1. So a and b having a 5 as a common factor is contrary to a and b both being co-prime numbers. Hence we cannot express square root of 5 as a divided by b. That is, we can say that square root of 5 is an irrational number. Now let's solve question number 2, which is prove that 3 plus 2 times square root of 5 is irrational. So let's start by assuming the opposite. That is, let 3 plus 2 times square root of 5 is a rational number. If this is a rational number, then we can find two co-prime numbers a and b where b is not equal to 0, such that 3 plus 2 times square root of 5 is equal to a divided by b. Now if we rearrange this, we get square root of 5 is equal to half times a by b minus 3. Now if we see this equation carefully, on the right hand side we have numbers 2, 3, a and b. All these four numbers are rational integers. So we can easily say that the right hand side of this equation, which is this, is a rational number. Now if the right hand side of an equation is rational, then the left hand side of that equation should also be rational if that equation or the equality sign has to hold true. Therefore we can say that square root of 5 is rational. But we know that square root of 5 is actually not equal to rational. So we use our general information or general knowledge that square root of 5 is irrational, but here we are getting square root of 5 as rational. It means that our initial assumption that 3 plus 2 times square root of 5 is a rational number is false. Hence, we can conclude that 3 plus 2 times square root of 5 is an irrational number.